Sta caricando. Perfetto. Allora. Ok, allora io esco dalla riunione e faccio diventare lei, professoressa, l'organizzatore della riunione e poi vedete voi se una volta finita se vi volete riunire con un altro link.
Sì, sì, guardi, noi già l'abbiamo, io l'ho già mandato il link, noi
Perfetto.
poi ci riuniamo, ok, tramite un altro link, così da qui usciamo e non c'è problema.
Va benissimo, allora arrivederci.
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 Sì.
Ok, prego, quindi possiamo cominciare?
Se per la commissione va bene, io la presentazione la farei in inglese. È possibile?
Per me va bene.
Per me non c'è problema, sì.
Ok.
Ok.
Now I will show the main part of the research I over last 5 years of my career. It has been focused on the position emission tomography, more specifically on the methods to recover 3D position on interaction in the PET detectors on monolithic crystal. The proposal of MindView project is the development of an state-of-art dedicated position emission tomography scanner able to visualize the neurotransmitter pathways inside the brain with the aim of improving the diagnosis of schizophrenia and other mental disease. The technological goal is a cost-effective PET scanner which the typical imaging perform of a small animal imaging device. Moreover, it must be able to work an insert with the magnetic resonance imaging commercial system, allowing to upgrade them into device providing simultaneous multimodal imaging. The goal of this project is a PET scanner with these capabilities: high sensitive module, high spatial resolution, and depth of interaction detection of the gamma photons. The technological choice made to develop a cost-effective PET scanner simultaneously working with the magnetic resonance imaging. And this scanner are a magnetically insensitive photodetection system, a monolithic scintillation crystal, and a simplified out electronic inside the scanner. In the following table, we can see what are the strengths and the weaknesses magnetic resonance imaging and position emission tomography complementary between this imaging technique make possible to realize an hybrid scanner, allowing to simultaneously obtain morphological and functional information. In other words, the hybrid scanner take into account anatomical detail and height sensitive to follow the picomolar amounts of tracer. The aim of this project is the realization that dedicated PET ring with the radio frequencies coils inside in order to obtain an integrated PET MRI device suitable for practically any existing commercial MRI scanner. I report two images into different visualization of the PET MRI insert. PET detection modules are commonly based on inorganic scintillation. They are able to convert the energy carried by the photons in visible light that can be detected by the position-sensitive photodetection system. But unlimited resolution and the low price of this type of crystal leads it to be candidate for this project. The following schematics show what happens inside the scintillation crystal when the gamma photon interacts with him, and how it is possible to recover the planar position of interaction and the depth of interaction from the light charge distribution. We report two different schematic situations. As a function depth of interaction, the scintillation light distribution varies, and if an gamma photon interacts near the crystal edge, the same issue in the light collection occurs. Check the following situation, especially for the edge interaction. An asymmetrical light collection occurs, and this effect is an unbalancing in the position estimation. In other words, the real position and the measured position is not equal, it's different. We report in this slide this effect, the image compression after the age effect. In order to solve the depth of interaction issue in the model level, to improve the imaging performance, the following method have been proposed. A position algorithm suitable for rows and columns light readout scheme. It provides the planar position interaction with just 12 plus 12 channels from row and column instead 12 by 12 channel, simplifically electronics. A method to obtain the depth of interaction position. It allows to solve the PET ring parallax error and the PET module compression, and the depth of interaction depends on the position of algorithm. Standard algorithm produce a trapezoidal response. The algorithm correct the depth of interaction effects. That to this method, it has been possible to improve the detection, the 3D position of interaction, the gamma photons inside the module, and consequently to improve the tomographic imaging capabilities of the scanner. We report some results. Parabola imaging performance obtained with raised to the power adapted to rows and columns, and the raised to the power based on single channel logic. Another parameter showing a strong correlation with the depth of interaction has been found, and this parameter allow a very good detection of the depth of interaction in experimental measurements. This plot reports the strong correlation with zeta direction of the depth of interaction on gamma photons. Finally, standard algorithm use the trapezoidal response, which you can see in the left image, the left panel, and effect which you can see in the right panel. This leads to increase of field of view from 28.9 millimeters to 39.9 millimeters, and improve the spatial resolution from 2.15 millimeters to 1.5 millimeters. These are the main results obtained, but these results are related to just one module of PET, and PET imaging is instead of a tomographic technique. So they must be translated in tomographic results from which dashed the diagnostic results. The next step is a for-switch approach. The depth of interaction parameters is suitable for for-switch detectors too. It is possible to distinguish different layers in the crystal system. And currently, the MindView prototype is already, and the first resolution made a phantom has been obtained from the data of D'Arienzo. We report two different reconstruction, respectively filter back projection, the least mode OSM reconstruction. Thanks for the attention. You have any question?
Well, may I?
Yeah.
Sorry?
Just a quick question, if I may. Can you go back to, it was one of your solution slides.
The solution, okay. One moment.
Yes,
Okay.
this one. Nope. After this, when you have the plot where the depth of interaction is. No, the next one probably. Yes, this one. So
okay.
In the plot that we can see on the right, you have expected and measured depth of interaction, correct?
Yes, expected and measured. Yes, expected Monte Carlo simulation.
And measured are those measured through the algorithm that you showed before?
Yes.
Okay, good. So the fact that you see some differences when let's say on the right part of that plot of those distances, is that expected or?
Yes, the spread. In other words, NIE, il parameter, is strongly correlated with the depth of interaction in terms of the integrated charge.
Okay, that's okay for me.
Ok. Marco, tu hai qualcosa da chiedere o ci siamo?
Scusatemi, no, it's fine also for me.
Ok.
Ok.
E allora penso che possiamo uscire da...
Ok, ci rimettiamo sull'altra chat che ci hai mandato?
Sì, forse è meglio, ok, usciamo da qua. Ok.
Ok, o come volete, non so se è obbligatorio stare qui invece.
No, per parlare noi no, perché io devo comunque scollegarmi da YouTube e no, è meglio che usiamo l'altra, dovesse essere... Scolleghiamoci, ok.
Quindi io... Ah, va bene.
Lei può andare.
Ok, grazie, arrivederci.
Ok. Allora,
Prendi là.
noi... ok.
Siamo sull'altra chat.